Hi, my name is Silent Dad. This video will contain solutions for the exercises in the C programming language book by Kernighan and Ritchie. Exercise 1-10. Write a program to copy its input to its output, replacing each tab by \t, each backspace by \b, and each backslash by \\. This makes tabs and backspaces visible in an unambiguous way. So we're going to use as a template here the file copy program, which basically answers the first half of this exercise, and then we're going to add conditions for when the input is a tab, a backspace, or a backslash. So let's see. So this is the file copy program, not the for variation but the while variation. So it's not such thing as a for variation, but the second version of the file copy program. Okay. Okay, so we're going to add the condition for when the input is a tab, a backslash, and a backspace. So if the input is a tab, so if the input is a tab, we're going to replace that with a backslash t. So we go, so to print the backslash character, we have to escape that. So if the character is a backspace, replace that with backspace backslash b. So if the character is backslash, again we're going to escape that. Okay, so if any other character aside from the previously mentioned tree, we just copy that character. So if c is not equal to tab, and if c is not equal to backspace, and if c is not equal to backslash, copy the character. So let's try to compile this and see the result. Okay, 926. So compiler is pointing out as to line 26. Okay. Yeah, I forgot the. Okay. So first we're going to provide an input without the characters that needs special attention. Normal input only. So it has copy what it has copy our input to the output. So let's so I'm going to input a tab character. So let's see if it will replace it with backslash t. So press tab. How about backspace? I'm pressing backspace, but it does nothing. So how about backslash? It should be slash backslash. Okay. So let's try again with the backspace. I'm going to press backspace. Nothing happens. So this okay. So remember when the book mentions something about the text string as the model for the standard library. String as in this. No, this one. Yeah. The model of input and output supported by the section 1.5. The model of input and output supported by the standard library is very simple. Text input or output, regardless of where it originates or where it goes to, is dealt with as streams of characters. In this case, our text stream originated from the keyboard. Okay. Streams of characters. And let's see. Okay, this what appears to be a character on the keyboard or a screen is, of course, like everything else, is stored internally just as a bit pattern. So everything that we type is being stored internally as a bit pattern. So what we see as our text string is actually a bit pattern which is stored somewhere. Okay, so when I press the letter A, its numerical equivalent is being stored somewhere as part of a text string. So when it is being when it is going to be displayed on the screen, it is converted to the actual character, which is A. Okay, so everything that I type here is being converted to a numerical value. So when I press tab, it is converted to its numerical value. So that's why when it is being read by the getChar function, it is being read because it is saved on a somewhere in memory as a numerical value, and it is encountered by getChar. It is being converted to backslash t, the same way backslash. Okay. But how about backspace? It should be, when I press backspace, I'm pressing backspace now, it should be saved as a text string, and it should be read by getChar, but it is not. So there is more to this. So it turns out that there is more to this. Let's look at the reference manual in the book, which is the appendix A of the book. The reference manual. Okay, so okay. Standard library. Ayun, this. A stream is a source or destination of data that may be associated with a disk or other peripheral. So our text stream is being saved somewhere. The library supports text streams and binary streams, although on some systems, notably Unix, these are identical. A text stream is a sequence of lines. Each line has 0 or more characters and is terminated by \n. An environment may need to convert a text. Oh, so that is why. So an environment may need to convert a text stream to or from some other representation, such as mapping /n to carriage return in line feed. So the environment, in this case our OS, is converting to something what is being pressed on the keyboard. That okay. So when I press tab, okay. So when I press tab, the numerical equivalent is being saved on the text stream, being saved somewhere. Okay, which is going to be part of the text stream. But the OS, when it's time to printing the character, the OS interprets that character as this, moving the cursor to some other position or some past or moving the cursor to the top position. So that is why when I press backspace, it is not being saved into text stream, but rather the OS do some operation that is what the backspace is supposed to do. So what is supposed to do? Delete the previous character. So that is, and it is not saving the numerical equivalent on the text stream. It's just deleting the character. So that is the reason why our getChar function couldn't see the backspace, because it is not being saved on the text in the text stream. Okay. So that is the reason why. Now, question now is, why did the author include the backspace? If include this condition, each backspace by \b, if it will not be shown in the text stream. So I would imagine that since based on the history of C, or based on why did they start creating the C programming language, it's basically to create an operating system. So maybe, just maybe, they're doing these exercises within the context of all the applications that will be used as a system programs. Okay. So maybe if we run this program without an OS, or natively without an OS, without the intervention of an OS, wherein each keystroke is being saved in memory, numerical equivalent of the keystroke is being saved in memory, including the blank space, before doing something on that text string. Before the OS does something on that text string, it will be read by our getChar. Okay, so how do we find out that this program is correct? If we can uh, satisfy this specific requirement by okay, so using the tab character. So even though we cannot see the tab being pressed, tab being saved, we know that tab is being saved on the string. Why? Because getcar can see it and it can act upon it. we, uh, and we use the same logic on other characters, so maybe this is working, this will work. And also if we can map our keyboard, so we can also do we can probably we can also map our keyboard or the backspace key to do something instead of override what the OS should do when we press backspace. Instead of doing what it is supposed to do, we can map it to do something else, thereby saving the numerical character as a the numerical equivalent of backspace, so that when getcar needs to write that string, it will be able to read the numerical equivalent of backspace and it will act upon it. Okay, but that creating that kind of file is not within the scope of this video. So also, so I guess that will be all for now, and I guess we pretty much satisfy the requirement of this exercise, and that will be all for now, and I hope you learned something.